Okay, so today's video is all about the B&O VX7000 VHS recorder or player. I purchased two of these from a gentleman on Facebook and through the B&O Facebook groups, and they were both purchased as not working, and they came with the service manual, and I just didn't want to see them go to landfill. I own two AV9000s, one of which has a 40 video player, which is actually a VX7000 in it. And I was interested to see what the players look like, if I could potentially repair these, and then hopefully repair my AV9000 to full working order. So on the bench, I've skipped ahead a little bit. I will show how to do this earlier in editing, but I've taken the covers off. And I'm just comparing the two units before I start, and there's some interesting differences. I don't know if you can see in the camera, you might be able to just. There are some jumper wires on the left unit and they are not on the right unit. The right unit will turn on and take a tape, but if you hit play it doesn't fully spool the tape, or the tape doesn't advance, so you get a still image on the TV screen for a couple of seconds before it gives up, so the tape isn't advancing. The unit on the left, I believe, has a power supply fault, and it won't actually turn on properly or do anything. It's very unresponsive. It comes up with like 4 zeros on the screen, and the tape is stuck in the unit because it doesn't seem to fully power on. So the unit on the right I'm going to put to one side for now, and you can see that's actually the cleaner and possibly the better of the two units. But I'm going to look at the first unit, the left unit, and we'll start by trying to remove the power supply, see what capacitors I need, recap the power supply, and see where we go from with there, because that's the dustier unit and the unit with the most critical fault, and we'll see how we go. So I'll bring you in for a closer look. Okay, so I brought the camera in for a closer look now, and you can see just how much dust is actually on this machine. It's it's quite disgusting. And hopefully you can see these jumper wires a bit closer now. There's some interesting work been done on this. There's a couple of jumper wires, there's a capacitor here, there's some sort of smaller component there. So I don't know if that was done at the factory or if that's been done in a repair over the years. We'll get into that eventually. These are obviously European units, so they're 2-pin plugs. So I've just got one of these proper conventional 2-pin to 3-pin adapters with a fuse. So I'm going to plug it in and I will show you what the fault is at the moment. Okay, so I'm going to plug the unit into the wall now. So that's the unit plugged in. So we can see instantaneously we've got those 8 symbol digits actually, and the unit is completely unresponsive. Now when I plugged it in earlier it did actually make a few whirring noises. I don't know. No, it's not gonna do anything now. So I understand from what I've been reading online that this is a power supply fault of some description. I'll just unplug it, plug it back in again. See if I can get it to do anything. Yes, we've got the exact same problem. Perhaps when capacitors discharge or something, it does something slightly different, but the tape is doing nothing. You can't eject it or make it play. So that's the fault. So we will start to look at how to remove the power supply next. Okay, so as mentioned slightly earlier in the video, both devices actually came with this service manual, and they are both the 4583 variant. And like I say, it does cover the control center VTR, so it covers the AV9000s as well. But for now, I'm referring to the pictures in this manual on how to remove the power supply. There is going to be a little bit of making it up as you go along because technical drawings are never the clearest of things, so we'll see how we go. Okay, so I think to start we actually need to remove this screw and this screw here and potentially that screw to see if we can get this back panel off and get this board to remove. So I'm just going to sit down and try and do that now. so that's that panel, and I wonder, does it just unclip, or are there screws underneath? There's something. Let me just put it on its front and I'll see. Okay, so hopefully you can see this. There's sort of like a metal through hole in 3 places, and it looks like you just, there you go, try and wiggle it off. Yep, there we go. And then the power cable comes out. So that's how we get access. Now I would assume that the capacitors here are faulty, so we'll see if we can remove this board. Okay, so sometimes if I'm not 100% which screws go where, I like to put them back into their original positions. So I'm just going to see if I can get that screw to go back where it came from. There we go, that's that one. I'll just do the same with this one. Oop. Okay, that'll be good enough for now. And then this one we'll just try and take out. Okay, we'll just see what that board is like. Looks like it potentially plugs in somehow. Oh, okay, I see. Okay, I think this this board actually has a few additional screws. Let me get a longer screwdriver. I think if I potentially take these 2 out here at the bottom, that may also help. Nope. There's actually another 2 screws on this side. So I'm just going to loosen off them and see if that helps at all. Okay, that gets the transformer loose. Doesn't seem to help with this, but let's unplug that because we want that out of the way anyway. Although it looks like it's just under this board, so I may need to lift that board as well. But let's see. When you're unplugging these ribbons, you want to try and be very careful with them. Okay, it does actually say on the back of the device, or the underside, disassembling instructions for qualified service and technicians only. It explains how to remove the side panels, which wasn't hugely clear, how to remove the top cover, and then it says remove the bottom cover as well. It says there's 7 screws. So we've got, what have we got here? We've got 1, 2, 3, 4, 5, 6, 7 maybe? I don't know. There looks to be more screws than it's alleging, but we'll try and take a few of these out, see if taking the bottom off helps us in any way. Yep, it's wrong. I don't understand why it says remove the 7 screws B. Because all of those screws had to come out and it's not coming off because there's still another 3 screws. So I don't understand that. So we will remove the additional 3 screws. Or maybe it's suggesting you don't need to remove them, you just need to loosen them. Let's try that. Okay. And that's the lower panel now off. And again, we can see here some interesting repairs. You've got some pads and some little additional components added. We will see. So moving back to the power supply and how to potentially remove that, we can see that there are some screws holding that baseboard down. So we'll need to look at that. Okay, so there's a couple of screws holding this in. There's a little black one down in here. So we'll try and take that one out. And then there's another one towards the back. It's essentially the ones that we could see poking through the bottom case. I'm just trying to remove here. And then there's another one which is in a really awkward place. It seems to be behind the capacitors, which is why I'm not 100% sure how you're supposed to get to it, but there we go. Okay, let's see how that reacts now. Okay, it's loose. But it's still stuck. Okay. So that is actually loose, but it's not going to be easy to remove. I think I may want to remove the screws for this board and just lift this board up gently to try and get to the transformer area. So let's just do that. Just 3 screws, I think, holding this on. Yeah. Okay. And I'm hoping that's going to let me lift this out now. Of course, before I go much further, I want to unplug it anyway, so let me just try and unplug this ribbon. I'll just unclip it. There we go. And there's a second ribbon. Oh, okay, that's going to be fun to get to go back in. And hopefully this one now come out. Yeah. Okay, so is that completely? Yes, it is. Okay, so this is the power supply assembly here, and there are different part numbers depending on where you purchase the device. There was 230 and 240, which is of negligible difference now. So you can see here the boards are labelled. So you've got board 51, and then I think this one should be board 52. Oh no, it also says 51 down in there as well. Okay, I'm just going to cut this bit in a bit early. It looks like perhaps you could have actually removed this board easier. There's a screw down in there, and there's a screw in the top right hand corner there. And I think if you remove those 2 screws, this board would have come off the assembly. What I don't know is how you unplug, or if you can even unplug, the ribbon that the transformer's on. I think they're soldered on. So I'm not sure how much help that would have been, but we'll remove those 2 screws now anyway. Okay, yeah. Okay, so removing those 2 screws has removed the board from the assembly. I'm looking at these caps, and hopefully you can see this. There's some permanent marker on them, which makes me wonder if they were replacement caps or if they were actually originals. We will find out, I suppose, when I take this cage off. So it looks like there's, yeah, it just clips over the edge and comes off. Okay, and then we'll just spin it round and have a look at the back side of it. I'm not sure, they could be original. There's certainly that brown glue on the capacitors that would maybe suggest they're original. Let me bring you in a bit closer here. I'll bring it closer to the camera. Can you see there's evidence of brown glue there? So potentially these are original. So I've got 4 large caps, 1 small cap. There's a small cap on this daughter board here, which I think is soldered into place as well. That one there. Okay, so I think what I'm going to do is I'm going to remove the 4 large caps. I'm going to remove the screws for this heatsink, remove the heatsink so I've got a bit more room to see what's going on. Of course, I'll check that fuse to make sure that fuse is okay. And we'll remove the smaller cap there. And I may look to desolder the daughter board as well, so that we can get in and give this a proper clean and see what is actually going on here. Okay, I'd quite like to remove the assembly from this metal cage. So I think the best way is there's a small cable tie here, which I'm just going to see if I can just snip. There you go. Just it's quite brittle anyway by the looks of it. So just going to remove that. Just see if I can slide this sort of heat shrink shroud back. And sadly, they haven't decided to crimp and spade that. I imagined that because those were essentially spade connectors that those were going to be spaded on, but they've actually been soldered. So we'll have to remove that. So if I pull that right back, hopefully you can see that. You've got live on the top and then you've got neutral on the bottom. So I'm just going to cut those for now. There we go. And that will remove the power cable and cage, and we'll deal with that later. And now you can see we've got the 2 independent boards, and we'll check that fuse in there as well. Make sure that one's okay. It's clean as part of the machine because it's got a cover on it. So we'll just check that when we get to it. So as stated before, I'm just going to remove the screws that are holding this heat sink on. It looks like there could be some thermal paste potentially in it, which would make sense, and that will need refreshing, I'm sure. It's a little bit of a shame that these cables are soldered in and so close to it, because it makes it very hard to actually get to those screws. I may need to try and pry the heatsink. Ah, there we go. Yeah, so there's a small amount of thermal paste in there, so we'll refresh that and give the board a good clean. Okay, so I don't want to have to keep turning and twisting and guessing on this board which capacitors I'm desoldering, so I'm just going to use a Sharpie to just put some dots so we know that it's those legs there, and it's there, that small one there, and that one there, that one there. That should be it. So I'm going to start up the desoldering station, add a little bit of flux, and see if we can get these capacitors out. Okay, so we're back. So I've been using these flux pens on all of my videos. They're only cheap. I'm sure it would do for now, but I've been watching a lot online recently, and there's possibly some better flux options out there that I didn't know about, so I'll be trying those in the future, but for now we'll try this. So I'm just going to use the the desoldering station, which again I've shown in previous videos, and we'll just try that. There we go. Okay, I might need some more heat actually. Just going to see if that's done the trick. I can see that the right leg, but the ground leg, so the ground's plane, isn't coming out, so we'll just try and get that out by hand. Hopefully you can see this. Hang on, let me move it back a second. There's glue holding that on. It looks to be the glue that's stopping that from coming out. So I'm just going to pull that out, and there you go. Now the only reason I'm not too worried about that is because it's a single-sided board. If that was a double-sided board you would not do that, so just bear that in mind. So when replacing capacitors, you always want to make sure that you check the orientation. You can see this board is actually denoted positive on the right, negative on the left, and the capacitor came out in that orientation, and the line is the negative, so we know that that was installed correctly. This one, positive on the inside, negative on the outside, and again we can see the negative line here, so we know that that's in the correct orientation, and that the board has been labelled or silk screened correctly. And again, I can see that the positive leg is loose, but I'm not so sure about the negative leg, so I'm going to heat and try and pull at the same time. Okay, I'm just going to switch to my iron because it will be more effective. So I'm just going to try and add a fresh amount of solder to this pad. Just see if I can get that to flow. Then we'll switch back to the desoldering station. It looks like it should be loose, but it's not. I do hate glued components, but we'll use the iron as well and try and get it to pull off. Okay, that was a bit ridiculous. It got there in the end. So the capacitors are 105 degree. So there might be replacements. We'll see if we can check them. They don't have branding as such that I can see. So we'll investigate that in a moment. So that's those two capacitors, and you can see, well, I'll show you that afterwards. Whilst I've got my iron on, I will add fresh solder to all of these caps. The ground plane is exceptionally thick on these, so I think I'm going to need some crazy amount of heat. I was on 370 there. I've just gone up to 410. We'll add some flux. See if we can get that to melt. Normally you want to be in a well ventilated area when you're doing this. I'm not, so I'm believing in flux fumes, which is not ideal. So let me switch back to the desoldering station and we'll see if we can get those out. So again, whilst we're waiting for the desoldering station to come up to temperature, negative on this one is on this side, which is correct, positive on the top. Negative on that one on this side, which is again correct, positive on top. Negative on this side. And again, you can just see a tiny positive on top there. So they are all orientated correctly, so I'm happy with that. So let's try and see if we can get some more luck with this. Okay, that seems better now. I've come up a little bit as well. I'm on 330 degrees on the desoldering, which seems to be melting it nicely. Oh, and that one must have just fell out. So that's fine. And then we'll just try the small one last. So like I say, positive there and negative there. And this one, nope, that's just fell straight out. And I might just touch them with the iron and try and pull them out. I think it is loose. I think it's just glue. Again, normally I wouldn't be this rough, but it is only a single-sided board, so I'm not too worried. It would be better off to use something like picks or something not as sharp as a blade. But that's what I have. So okay. Then that one, I think it's just got a little solder blob on it, so I think with the iron that one should just come out. So that's the capacitors all removed. They don't look to have leaked. Everything looks very dry, so at this stage, a bit confused why it's not working. So we'll get the tester out and just check these capacitors. Okay, so now it's time to test the capacitors. They've all been removed from the board, well, except for the one on the daughter board, but we'll do that later. So I need to check the tolerances to see what values they are and if they're still in spec. So this tester, just a cheap tester you can get on all the different websites. I think that you can get it on Amazon and stuff like that. This link's going to be in the description for anybody that's interested. So you just rig up some wires to the leads, and then you wait. And you can see this particular one, it says 2037 microfarads and an ESR of 0.08 ohms. And this was the 2200. So it's not quite there, but actually when you check the spec, that is in spec because it's got a 20% tolerance on it. Now, I've done all the other ones off camera. I'm not going to bore anybody with that because I've been accused of being boring. So, but this one is the one that's interesting, and I think this could be my problem. So this is the smallest, well, second smallest capacitor on the board, and I've had this size capacitor sort of fail in the past, so that's quite interesting. So if we test this one, this should be 10 microfarad, and we can see we're at 0.8 microfarad, 8,000 nanofarads. That's not the interesting bit. The interesting bit is the ESR value. If I do that again, the other one was 0.08 ohms, which is a low ESR, which is fine. This one, if you look at the capacity, it's in spec, but if you look at the ESR, it's 0.15 kilo ohms, which is wildly out of spec compared to all the other capacitors. So I suspect a high ESR means a failed cap in some capacity. So I suspect that this is probably my failure point. So I've documented all the capacitors, put them in a spreadsheet, and I'll bring that up on the screen in a second. So just before I move on to the next sort of section, just wanted to explain how I came up with the spreadsheet I'm going to show in a moment. And I've used a set of digital calipers or verniers, and these are just a cheap set from Lidl. You know, they're very, very cheap, but they're handy devices. So you can do the outer diameter with that. If you had something with an inner diameter, which I do not have to hand, so I could just, for example, maybe use this screwdriver handle. So you could do that, and you'll see that the inner diameter of that hole is 6.3 mil. Or if I had something with some sort of depth, for example, maybe this network adapter here, the back end of it, it's got a bit that comes out a spike, and you could put that in and check your depth, and you would get your depth on the screen. So it's got 3 different measuring capabilities, which is quite nice. So if we use this for the capacitors, I've just got the capacitor there, popped it in the joules, and we can see that's roughly 12 something mil, and I think the expected value is 12.5 is the expected value for this, comparing it to other capacitors. So it seems to be a little bit over, but that's absolutely fine. And same with the length, just pop it in between the joules, and we've got a length of 39.4, and it should be about 40, it's a 40 millimeter length capacitor. And then the last thing is the leg spacings, and the leg spacing on this should be 5 mil. So if we bring it down to 5 mil, and we can see that the legs, see if I can show you that, leg spacing is 5 mil. Okay, so that's how I've checked all the capacitors to log them, and I'll bring that up on the screen in a moment. So just before I bring the spreadsheet up on the screen, I just wanted to show some other bits before I desolder the daughter boards to get that last capacitor value. I've got the cheap scope out, which again is links in the description. And I'll bring this up on screen in a second, but I just want to check the board to check the quality of the soldering and see if we've got any sort of failures of the solder joints. Just see if I can bring that in a bit closer. And the things that we are looking for are things like connectors and values that would, or components that would get hot. So I'm looking for things that have got quite large pads, and you can see here we've got some large pads, and the left one doesn't look too bad, but the right one, you can see that there is a sort of colour change, like a ring, like an outer ring, and I wonder if that's signs of that starting to maybe become bad. More accentuated rings are definitely bad, where you would see cracking. These don't actually look like that, but I will probably just go over them anyway. Let me have a look here, see if I can find anything of interest. Yeah, this one here. Look at that's cracking. That's got cracking on it. What does that say? That says D something 54. D854. That's definitely a failed solder joint. I didn't spot that when I was looking earlier. That's quite interesting. So what is that on? That side, debatable. But that side is definitely failed. So that would need reflowing. So what I'll be doing is I'll be going over this board and I'll be looking for different, again there, it doesn't look too great. It looks like there could be some cracking in that. And that's one of the pins on one of the devices that had the heatsink on. And they don't look spectacular, to be honest. So I'll be cleaning and reflowing that. Again, that one you can see on the lower edge. Sorry, I'm shaking a little bit. On the lower edge, you can see, if I can focus it, hang on. Let me see if I can get that to focus. Yeah. You can see ringing on the lower edge there, which makes me think that that could be becoming faulty as well. So I'm going to go over this board, and if I see anything else like that, like this is the connector here, so that would definitely get reflowed, but it's quite fine pitch, but you can see there some ringing on that. I'm going to see if I can zoom. Yeah, so hopefully you can see that. And that looks like that could be cracking in the solder joint. So all of that will get reflowed, and hopefully we can get this working again. So that's that board. Let me quickly move over to the transformer board, which this is going to be way too close to that lens, I suspect. Yeah, it's definitely close, but we'll see if we can get something. So this is the legs for the transformer. And there's pitting in it. There could be a crack on the lower edge there. That one looks okay. I think that one looks okay. Again, some ringing. Looks fine. So I'll go over all of this anyway, and we'll see how we get on. Okay, so here's the daughter board desoldered, and hopefully you can see the layer of dust on that. I'm going to bring it up on the scope now, and yeah, the level of crust on this is ridiculous. Let me just get some tweezers out here. Let's have a look. Oh wow, that's quite a level of dust. It's just ridiculous. So I'm going to clean this board You couldn't even see the part number under all that dust. There was just that much. So yeah, I'm going to clean this board and remove this little capacitor here. And just in case anybody was wondering, that's what that chip is. And yeah, it desoldered fine. So we'll give it a clean with some alcohol and some brushes, get that cap off and go from there. Okay, so that's that capacitor removed now. As you can see, it's removed. I just peeled back the insulating sheet on the back and desoldered that. So I've cleaned up the board. Just went over it with some IPA and a brush. And you can see there's still a little bit of residue on there. But for the most part, it's much cleaner than it was. So that's fine. Now, interestingly, this component isn't actually labelled on the board at all. And I can't see the board listed in the service manual under the electrical components. I just don't know why I can't see it there. So I went through the diagrams, and page or part 229 is the diagram for the power supply. And it says 52 switch mode power supply, and then there's the daughter board in the middle, but it doesn't give it a name as such. But following it around and looking at the schematic, I can see it's capacitor 865, which is denoted as a 10 microfarad, which, there you go, 10 UF, 16 volt. And this is M rated for tolerance, which is 20%, and then 85 degrees. So we'll go over to the spreadsheet now. So here's the spreadsheet that I've been fretting so much about over the last couple of minutes. What we've got on this spreadsheet is the information that's come from the service manual and some little bits of information that I've worked out myself. So in the service manual, it lists the components here. So this is the respective capacitors that are listed. You can see we've got, should be 6, yep, we have 6 capacitors that are on the power supply. There is a B&O part number, which is sort of irrelevant now, but I've included it for historical reasons. The expected values of what should be there, the voltages, the current temperature ratings of those capacitors, and then, like I said earlier, using the digital calipers, working out the correct values, so leg spacing, length, diameter. This information actually is not included in the service manual, so you have to work that out from the original capacitors. So by including this here, it saves you a job of desoldering and working that out. All of the capacitors were denoted as M, which is a 20% tolerance. There were additional markings on the capacitors, which I don't actually know what any of that means. I assume that SXF, SME is possibly a like a range of capacitors. But there were no brandings on it, so I don't really know what those ranges are about. We've then got a simple thing that says, is it in spec, yes or no? And then what the 20% tolerance range is. So, for example, if we take the top one, so it should be a 2200 microfarad, and that range at 20%, it's in tolerance if it's anywhere from 1760 to 2640. So the stuff in blue is the stuff that's relevant to the actual capacitors that I've taken out. So we can see here actual values. So you can see with my tester, this is the values that I got. Loosely, all of the values actually look to be in spec. They look to be close enough to what they should be. But like I said, the ESR is where it gets interesting. That's quite low. That's really low. That's really low. That is really high. 0.15 kiloohms. Strange, absolutely strange. And you can see I've included the VLOS column as well, because I find that quite interesting. And you can see a guess, you'd say, oh, 16%, yeah, there's something wrong here. And this is, apparently it's a voltage drop. I don't know the ins and outs of it, but I'm just looking at figures and saying, yeah, that looks wrong. And this one looks a bit iffy as well. So it's quite considerably higher. Same with that, 4.3 ohms. So what I've done is I've done some calculations here. So we've got a formula up here, and it's some sort of, you work out the difference and then do it by the tolerance, and it'll tell you if it's true or not. So at 20%, we can see that that's fine, that's fine. That I've done as a manual no, because we pretty much know it's failed because of the ESR value, but they've all come back as true. The interesting thing that I like with spreadsheets is if I change the tolerance to say 10%, you can see the range just jumps there because the range is changing. So if I change it all to 10%, we can see they're all still in spec. If we went down to 5%, that's when you'll see it all fly to false, I think. Yeah, they all go to false there, just out. But not hugely out. The lowest energy of a 5% is 2090, 2079 there. So not a world away, but that's how you can easily work this out. So I quite like that. That's the spreadsheet on the values. So with the collecting of information out of the way, it's now time to actually go and build our capacitor rebuild kit. And there's lots of information out there on how to do this, but I think the best person I've seen that's been able to describe this is actually Steve at RetroTech. He's the only YouTube channel I've actually Patreon subscribed to. Really love the guy, love what he's doing. If you go on his channel, you'll see how to build capacitor kits here, how to create your own capacitor kit, all about different kits, all about working out what's the best to choose. I'm going to summarize the information for my video, but please go and have a look at his channel. So we're going to head over to Mouser. We're going to type in capacitor, and we're going to go and pick aluminium or aluminum, whichever way you want to call it, electrolytics. And at this point, Mouser is really good because you can have tons and tons of filters. So all of these capacitors are actually through-hole radial capacitors, so we'll pick that. We'll just do that straight off the bat. And now is the time to filter down to what you want. So I'm going to pick this capacitor here, 1500 microfarads. So you go and find the value. And then we're going to have a look at what the voltage, so it says minimum it has to be 35 volts, so we'll go and pick 35 volts, but it doesn't matter if it was a higher voltage rating, it just means it will be more tolerant. So I'm going to pick 35 or higher, just in case there's a capacitor that will work for us. I'm going to hit apply. Then we always want to use 105 degree or higher capacitors, so I'm going to pick that filter, apply. And now we get down to the specifics of what we can deal with. So it has to be a leg spacing of 5mm, so we can do that. And we have a diameter of 12.5mm, so we'll go with 12.5mm. But if it was a smaller capacitor, it wouldn't matter, it would hopefully still fit on the board. So we can go 12.5 or less. And then we have a height restriction of 40mm, which we can go 40mm or shorter. So I'm going to hit apply. So now we're down to 39 capacitors. Then it's always a good idea to say, is it in stock? Because you don't want to select a capacitor that's out of stock. And at this point we can see we've got 15 options left, okay, based on the information we've given it. Ideally, I don't know if Mouser allows you to select tolerance at this level, doesn't look like it, but if it did, you would select 20% tolerance. So now we can have a little look at what options we've got. Now we've got manufacturing options. Nichicon, Panasonic, Rubicon, all good options. I prefer Nichicon if possible, so we'll go with that. I'm going to hit apply. And then the last thing, ideally, it would be amazing if we could have a real high life hour capacitor, but that may not be possible. So we'll have a look at our options. And you can see here, this is the option that I've picked before. This is the option I've actually got in my kit. There's only one in stock, unfortunately, because I think I ordered the last couple that was there. But we'll have a look at this capacitor and go through the process. So this is the one that I was suspecting would be good for me. So let's have a look. So yes, it's a radial. Yes, it's 1500 microfarads. Yes, it's 35 volts, 105 degrees. Diameter is 12.5, which is is what we were expecting, good. The length, so it's a little bit shorter apparently, which is fine. Nice high life hour, which is good. And there's the key look tolerance, 20%, so it's the M rating. So that capacitor looked to be a good fit. You've also got the data sheets as well, so you can have a quick look at the data sheets. And we can see that it's high reliability. Should be a good capacitor. So it looks a good fit. So I went ahead and ordered that. So once you go through your entire list and work all of that out, I then built up a little project. So I've got a project here, BO VX7000, and this is all the capacitors that you need. So what I could do in the future is if I wanted to build this kit again, or do another one, sorry, I could just say order project, check that out and purchase all the capacitors I need. So on screen now is obviously all the capacitors I've ordered for this kit, and I'm recording this a little bit out of order, so I've already fitted these at this stage and I know that the power supply works, so I'm happy with that. One thing I did notice is one of the capacitors was slightly longer than the original, slightly taller, but it was actually shorter than the overall height of the board, so it's perfectly fine. Normally you wouldn't want to make that mistake, but that was a mistake I made in this instance. But you can see total cost here, £8 for capacitors, and if that rebuilds your power supply, then brilliant. You've fixed obviously an old, but what was £1,200 or something new VHS player for £8. So absolutely brilliant. So that's what you do. You order it. As long as your order is over £33 in the UK, you get free international sort of 2-3 day delivery from America. Absolutely amazing. And that's all you need to know. So I just wanted to take the opportunity to show the new capacitors compared to the old capacitors. And similar to earlier in the video, I've used the tester to check the values of that, and I'll show that in a moment. But you can see that the capacitors are very similar. So if we take, what have we got here? Yeah, if we take the 2200, so you can see they're the same diameter. And then if we look at the height, it's ever so slightly shorter as anticipated. And you can see this is the Nichicon equivalent. The leg spacing is the same, so the leg spacing is good. So it should be a good fit, good alternative. As I mentioned in the spreadsheet video, there is one, yes it's this one I suspect, 2200, yeah. So this one I accidentally got a slightly higher capacitor, but when it comes to the board, which I'll just try and bring into view here, this actually, is it in view? Just bring it in a bit closer. When this capacitor is in the board, it's actually not going to be higher than the heatsink, so it's not going to be a problem. So I've got no issues with fitting that capacitor. So you can see here that we've got all the replacements, and the miniature capacitor, which I was quite concerned about, is a good fit. It looks to be essentially the same size, and then the one that sits on the board as well, it's essentially the same size. I think this was the only one. Oh no, that's Nichicon as well. It must be this one then. This one must be the, I think this is a Rubicon. It's the only one you couldn't get. So I'll solder these in and go from there. But we'll switch over to the spreadsheet now, so bear with me. So looking at the spreadsheet, there are a few hidden columns. So let me just unhide those columns. Unhide, there we go. So what I've done here is I've repeated what I did on the original capacitors, and I've repeated it on the brand new capacitors from Mauser. And we can see that the values are somewhat similar, somewhat more accurate as well. But of course the interesting thing is look at the ESR values and look at the VLOS values, and we're going from 1.5% to 0.9%, 1% to 0.6%, 16% to 0.3%. This one struck me as interesting. That seems to be a slightly higher value than I was anticipating. But for the most part, you can see that the values are much, much lower than the original ones, so they're much closer in tolerance. Clearly new capacitors, and clearly should have quite a good life. So that's all I needed to show on that, and it will be on with the show. With the capacitors out of the way, I wanted to sense check what else could be wrong with the device. And reading online, one of the key things that it was mentioning was the battery, which is mentioned here as part 3 of the diagram. Now, if we look at the actual diagrams, it's not the clearest diagram in the world, but it seems, I suppose that this top one is face up, it's like it's sat down. You see the tape mechanism here and the boards and the power supply. This must be the underside of the device. And we can see that it seems to suggest you've got a large board here, you've got the tape mechanism here, and then you've got part 3, which is sort of hidden somewhere towards the front underside of the device. So that's what I'm looking for. It says that part 3 battery is on page 217. So if we go and have a little look for that, 217 is hidden here, and we can actually see, here, yes, board 3 is the battery, and we can see that we've got 3 cables going to that board. Now, if we go and have a look at the electrical components section, which is further towards the back, we can see really early on, I'm just going to bring it into shot, we can see that we've got PCB 3 here and a part number battery, and there's no parts listed, so this is one of the few components that would be considered a consumable, I suppose. And I don't believe there's anything further about it in the book. So what we'll do is we'll flip the VHS over and have a look for that part. Okay, so I have the player turned over, and as I said, this diagram isn't particularly clear. I wish they had some sort of arrow direction on which side was which. The part 3 is actually at the back, not at the front. So this is the front and that's the back. Which wasn't immediately obvious. So anyway, I had a look about. I was looking at the VHS player here, and it's actually this little board here. So there's one screw for it, so we can undo that screw. And the board, you want to slide it in this direction because it's sort of clipped. So you lift it slightly, try and, there we go. So now it's loose. Now my cable was very tight, so trying to actually get this out was very, very complicated. But you can see here it's a Maxell battery. It's a AA size, but it's a specific type of battery. It's actually a ER6 AA 3.6 volt lithium cell. Now you notice I've got quite a bit of clearance on my cable, and how I did that I'll show you in a moment. Okay, so we're back on the top side of the player. I've just got this screw in loosely just to stop this board falling about, so I just take that back out. So I had to follow the wire, and the wire is hidden right underneath all of this cable management. So we'll just pop this board back out. Just flip it over. Cables are very tight. Now there is some cable strain relief. There's some there, which mine has come undone. There's a little bit here. Now when I had a look at the cables, they are red, orange and brown, and you can see them here, and then you can follow them, and it comes over to here and it says do not disconnect unless replacing the lithium battery. So I'm going to disconnect that there. And what I did is I lifted this strain relief, and there's a bit of cable tucked in here. So I lifted it slightly, pulled the slack loose, and then pulled the battery from the underside, and that's how I got the clearance to actually get that battery to come loose. And that's how I've done that. Okay, so with the cable slack now available, I've been able to pull this gently out a little bit. Now if we have a proper look at it, like I say, you can see it's a battery cell, and it's got a solder tab on one side. It looks to have some sort of elaborate pin cable coming off the positive side. Now it's got like a sort of heat shrink around it, but obviously that's going to have to be cut to get that battery out. I'll just have a look, see if I can find my knife. So just get a standard craft knife, and I'm just going to try and cut that heat shrink. It's actually quite thick. And this is probably not the sharpest of knives. Obviously, standard rules apply. Be careful with blades. So there's sort of a plastic shim underneath the base of it. And then there's that sort of heat shrink tubing. And I'll see if I've got something thick enough to go around to do something similar when we replace it. Similarly to elsewhere in the system, that cable appears to be hard soldered. And you can see on the board there are a couple of various components. We've got some diodes, quite a few diodes actually. So what we'll do is I'll just get the cutters, and I'm going to have to cut this battery out because what I don't want to do is I don't want to desolder it and present heat to the battery and potentially have an electrical fire or some sort of problem. So let's see if I can cut that out. There we go. So that's the battery removed. Now you may wonder why haven't I tested it. I'd already tested it, and it's literally millivolts. It's not 3.6 volts, it's like 3 millivolts. So it's long since dead. So I will bring you in for a closer look of this board quickly, just so we can see what that looks like. So hopefully you can see that board, you can see where the battery would have sat. You can see it's got a part number there, and you can see a part number of the resistors and the diodes. It's quite a simple board. I imagine it's some sort of overload protection or directional protection, because it's not a chargeable cell. So if we have a look at the cell, it's a Maxell Super Lithium ER6 AA 3.6, made in Japan. So that's what I need to source a replacement for. I'm not sure if Maxell still make these. There seems to be some later revisions, ER6C and stuff like that, but I found a website in the UK that actually seemed to stock something very similar to this. So I'm going to look to... Oh, it's not focusing. I'm going to look to order a couple of those for the respective VHS players. Okay, so I'm just doing a voiceover on this part because there was other things going on at the house, so I didn't record the actual audio of me doing this. But here is now the replacement of the capacitors. So this is me preparing, just cleaning the soldering iron tip there, just pulling off some solder. I've shown this solder in other videos. I prefer to use 6040 leaded solder, and it's 0.38 millimeters, so it's very fine, which allows you to control what you're doing. And you'll struggle to get it now because of the lead in it, but you can still buy it if you've got some sort of business entity. This stuff here that you're seeing with the plunger, it's actually the new flux paste that I was talking about. And this is not the one that was used in other videos, but this was based on videos I've seen, that this stuff as a paste seems to be better than the liquid flux pens. So this is just me preparing the flux syringe. And in a moment I'll get into the actual video of me doing the resoldering of the capacitors. So what I'm going to do is I'll do it as a sort of sped up time lapse. You can see me applying the flux there. And we'll smash through this and I'll be back with you soon. So that is the soldering work done on this board now. This is just me checking over the board, just making sure that I'm happy with how it looks. We'll flip the board over in a second. There we go. And that's the work complete. That's the daughter board soldered back in. Quite happy with how clean it looks. And we're ready for testing and moving on to the next stage of, did it work? Okay, so I'm just in the midst of reassembly now, and just noticed something that I thought would be worth mentioning. The screw that I was concerned about early on, that I couldn't work out how you had to get to, you don't need to get to it, it's nothing to do with it. So there are 3 screws, I think, which is that one down in there, that one there, and then that one at the back there. 3 screws. So those 3 screws will remove that cage. The cage seems to need to be lowered down in vertically, hence this board is moved well out of the way to allow that. And once I've noticed that, I will screw this board back with the 2 little screws. It's all coming back together now, and then hopefully shortly we can test and see what's changed. Sadly, I don't have a new battery yet, that's still in the post, but it was very low on voltage anyway, so I'm thinking, you know, we may have a chance, so we'll see. Okay, so I've reassembled the VCR. The bottom isn't on, but it's on this protective mat, so it should be okay. The power supply is all back in. I haven't put the back panel on the power supply area yet, just in case we see any sparks fly in a minute. Like I say, the power supply is rebuilt. The battery is missing, but I don't think that's a huge issue in terms of power up, but we'll see. So we're looking to see if it's got a similar fault, or potentially a different fault, or potentially it powers up. So I'm going to try and plug it in. I haven't tried this yet. It's going to be interesting to see what happens. I'm going to try and watch it as I plug it in. So here we go, 3, 2, 1. It's plugged in. What's happening? It's doing the exact same thing. Exact same fault. So, assuming my soldering is good, the problem isn't the power supply. So what I could do is I could switch my rebuilt power supply into the other unit, which of course we know does power on, and diagnose from there. But yeah, at the moment, exact same fault. Okay, so I've just got a minor update for you. I've put the rebuilt power supply in the good VHS, and when I plug this in, we get the exact same fault. We get the 4 8s. So the fault is the power supply. But I don't think it's the electrolytics, because I've obviously replaced them and I believe my work to be good. So there must be an additional fault, potentially diodes or one of the ICs. So what I'm going to do is I'm going to unplug it, take the power supply back out, and I've obviously got the good power supply and the now bad power supply, and I'm going to have to start comparing values and see if I can track down what potentially the fault is. So I'll be back with you soon. Okay, so I've taken both power supplies apart a little bit now. Here we have the rebuilt one, which I've worked on. Here we have the working one, which I obviously have not worked on. And I wanted to start checking and testing. Just to reiterate, I have tested all the fuses, and all the fuses are testing good for continuity. And the way the power supply is laid out, I have the diagram here, and I'm going to put that on screen in a moment for you. I'll scan it in. So hopefully that's on screen now. So it's stating that the board should be split into 3 boards, board 51, 52, 61. I don't know why, but both boards say 51. You can see 51 there, and you can see 51 there. So there seems to be a bit of a mismatch there, but the rectifier board, which basically seems to be the transformer board, is this one. So this should be for board 51. And there's not really anything on it to go wrong. So as long as the fuses are testing good, I can't see that's likely to be the problem. So I'm going to ignore that board for now. So let's come to the more complicated board, which should be the switch mode power supply board 52. And off camera, I've done some quick testing, and I've tested the bridge rectifiers, the diode gates, which are D852 and D851, and both test pretty much identical. So I don't think it's the bridge rectifiers at fault. But then if you look at the diagram, towards the top, we have something called R871, which is a fusible resistor. And that just jumped out at me because, as far as I'm concerned, fuse sounds like something that would blow, fusible resistor. So I still can't find my good multimeter, so I've got this abomination that I hate. So if we put it into ohm mode, or resistive mode, now if we check on the good power supply, this is the part here, by the way, R871. Oh, come on, wake up. It's testing at 10.4 ohms. And it says it should be a 10 ohm resistor. If we do the same thing on this power supply, and we test between the pins, it's gone up into the mega ohm range, and it's drifting a lot. It's 11 mega ohms, it's 12 mega ohms, it's 13 mega ohms. It's just rising and rising. 14, 14.6, 14.7, 14.8, 15. It just keeps going. So it's flying up in the mega ohm range, which obviously is wrong. So I think something happened. Maybe there was an electrical fault in the power supply, because we did see that some of those capacitors looked a bit iffy. Or potentially, a lightning strike, something like that. I think that resistor is blown by design. So what I'm going to do is I'm going to fire up the desoldering station, desolder that resistor. We'll test it again out of circuit and just see what that looks like. And then I'll need to either order one, which would be really tedious, or I'll have a look and see if I've got one hanging around. I think I've got a resistor kit from 10, 15 years ago. So we'll see if we can find something. So let me desolder that and I'll come back to you. Okay, so hopefully you can just about see that. So here is the resistor desoldered. I'm just going to try and put the legs on. It's reading nothing. Maybe desoldering it has finished it off. Yeah, I think that's blown open. Okay, that's a shame. It would have been interesting to see what that, if that would have read the same out of circuit. Let's have a look. I'm intrigued to see if I just do the pads. I'm just going to see if I can just read this across the pads here for you. Okay, so hopefully you can see that. That's 12 mega ohms across the pads, which I'm guessing is correct. I don't really know. But it just shows that, yes, what I was reading was actually the circuit, not the resistor. So what we will do is I'll see if I've got one of these and go from there. So as we know, this resistor is dead. So I've had a little look through my box of junk, and I found this kit, which you can see here, a set of 480 resistors, and it says that it should have a 10 ohm on there. So I've had a look through, and sure enough, there is the 10 ohm resistors. And I bought this kit before I could drive. I imagine I was 15, 16. I rode my bike all down the bike tracks to Maplin, which obviously is no longer there anymore. But I bought this and I've never thrown it away. And today we might get to actually use one of these resistors. So I've checked them, they are definitely 10 ohm, and you can see that the bands match. So yeah, I'm going to take one out, solder it in and see how we get on. So just quickly, I'm just looking at this card. They say on the front that these are 1/4 watt, 5% tolerance resistors. Now the interesting thing is if you look at the back of the card, it says gold tolerance there. It says gold is 10%, silver is 5%, which struck me as a bit strange. And if we look at the service manual here, it actually says resistor 871, 10 ohm, 5% quarter watt. And if you look online, it's sure enough, it says a gold band is a 5% tolerance. So somewhat interestingly, this card is actually a misprint. Silver and the gold is round the wrong way. Okay, so the resistor is soldered in, so I'm just going to give it a go on the old multimeter now. This thing is absolutely useless. Come on. There we go. 10.5 ohms, 10.4. So that should be pretty close to the other one. Let's have a quick look at that one. When it wakes up, 10.4, 10.3, 10.2. Okay, so that's that problem fixed. So I wonder if that's it. Is that all we're up against? I think there's another resistor after it in circuit actually. Let's have a look. Let's just check this one. Oh god. That doesn't look too clever on the good power supply. Nasty bit of crud on that. So we've got what's this? R878 is that? Let's have a look at what it is on the good one. 334k maybe. Let's have a look on the bad one. 320k and rising. I don't know quite why it's rising, but we'll say the soldering doesn't look spectacular on it. I might just put a little bit more solder on that. So I'll just touch up the soldering on that, and I think I might reassemble it, give it another go, see how we get on. Okay, so here we have the good VCR with the rebuilt, so bad power supply in it for now. I'm doing it this way round because I don't know if something in the other VCR is blowing it in some way. So I'm going to plug it in. So let's see what this does. Hopefully it doesn't go bang. Right, 3, 2, 1. Okay, that was different. It did the 4 8s and then it's doing nothing now. Oh, we have a standby light. Will we get the two sort of little lines on this, I wonder? I think when it fully boots you get some little... Yeah, there we go. It's booting, that's it. Good. So, tape. I know obviously it won't play, but... Yeah, it's spooling badly and it's going to go wrong, so we'll eject that. Ha! One fixed power supply. Awesome. So, thank God for that. So we've obviously replaced the caps, which is preventative maintenance. They may have been part of the problem. But the actual problem was that resistor. That's amazing. Good, okay. I think I'm probably going to leave this video here for part 1. What is it now? It's Easter Friday today. So I've got next week off of work, so I'm going away for a few days. Catch my breath, catch a break. So yeah, I'll upload this as is, and we'll see you in the next parts. I'll do this in parts, which is unusual for me, but we'll do it that way. And start looking into why this one will not spool up properly. What I might do is I might rebuild that other power supply whilst I've got it out quickly today. Get the other one reassembled, see if that one successfully powers up, and go from there. In fact, I'll do that. I'll rebuild that other power supply quickly, chuck it back in the other VCR, and we'll see if that one powers up. That's going to be the test. Good. Back with you shortly. Okay, so we've actually missed a step here now, so I'm just going to tell you what's happened. Somebody rang me and I was chatting on the phone, and I finished rebuilding the original good power supply. Put it all back together. I put it in the bad VCR, plugged it in. It came up the 4-8 symbols, the 4-8 zeros, whatever you want to call them, and they went out. And then I said to my friend on the phone, I said, oh, it's booting. I'm just waiting for the standby light. And I waited and I waited and it was dead. So I unplugged it and I plugged it back in again and it was completely dead, absolutely nothing. So I said, well, clearly something's gone wrong, clearly it's damaged. Took the power supply back out, I checked it, the fuses all seemed to be okay, but I checked the resistance on that resistor that we replaced, and sure enough it had gone well out of spec into the mega ohms again. I desoldered that, and unlike the other one that blew clean open, this one was still connected just about, but again it was at 45 mega ohms rather than 10 ohms. So I've replaced the resistor, and I've now put the good power supply in the good VCR. And I'm going to plug it in, but I have just noticed that I haven't actually connected the ribbons, which are very, very important. So the good VCR with the rebuilt, what was good power supply in it. So I'm hoping if I plug it in, that this is going to power up successfully, and then we can prove that we've got two good power supplies now, and the fault is actually with the main boards in some way. So I'm going to plug it in now. We've got the 4-8s, it's gone off. I'm really hoping it powers up to a standby light. There's the standby light, okay. We press play, we get the 2 dots, okay. Now this has developed another fault in the meantime. It seems to do some interesting rewinding now, so we'll see if it does that again. Yeah. So now, rather than doing the thing where it was playing and struggling to spool, now it's stuck in some weird, I'm going to rewind the tape loop. And it's doing it, that's twice, I think it does it 3 times, maybe 4 times, and then it will eject the tape. That's now a faster rewind, and then I think it will stop and then eject. There we go. Yeah, so it wasn't doing that before because it was just sort of attempting to play without being able to spool the tape properly. So it's got a slightly different fault, which, you know, mechanical faults. So good. So we have 2 working power supplies, and the bad VCR, if you plug the power supply into it, it's killing them. So that's a problem for another day. So I think I'm going to round up now, finish editing up the video, and see you on the next one.